Good morning, viewers. Welcome to this lesson. This is Mwalimu Omondi Johnny, teacher at Parklands Baptist Academy. I've been in this profession for the last 9 years. This is my 10th year handling mathematics and science. Our lesson today will handle mathematics, which will take us approximately 1 hour. We are going to tackle topic measurements and specifically area of borders, area of varied shapes, and area of combined shapes. Welcome. As we move to area of combined shapes, there are factors which we must consider, because we have different shapes. When they are put together, they form what we call combined shapes. So combined shapes, which means we have different shapes, like a circle, we have a triangle, we have a rectangle, we have a square, we have a rhombus, we have a parallelogram, we have trapezium. So these are the shapes we are going to handle when they are combined. For example, you may find a circle joined together with a triangle. So what are you supposed to do? The first thing, you must know how to find the area of the circle, which means area of a circle is equal to pi r square. What about if it is half a circle? A half pi r square. Area of a triangle is half base times height. Area of a rectangle, length times width. Area of a square, side by side. And we have another formula for finding area of a square in case you are given diagonals only, because for the square, diagonals are the same. So what do? We say diagonal times diagonal over 2. What about rhombus? Rhombus, the area of a rhombus is base length times perpendicular height. Rhombus also has another formula, which is smaller diagonal times bigger diagonal over 2, as you can see there on the board. Area of a parallelogram. Area of a parallelogram is base length times perpendicular height. Then we have area of a trapezium, which will use height over 2 into bracket a plus b. Some people use half into bracket a plus b, close the bracket, times h. It is the same as h over 2a plus b. Then you check on the lower side, we have Pythagorean theorem, which is right angle relation, which is a square plus b square is equal to c square. That one will be assisting us to get the sides which you have not been given, especially when it is a triangle and you have been given 2 sides and you need the other side to find the area of a triangle or area of the figure. We will be using that. Then I want us to check the KCPE analysis, the previous KCPE analysis. If you check the previous KCPE analysis concerning area of combined shapes, area of varied shapes, and area of borders, I did the analysis from 2010 to 2018. We can see each year there is a question which was brought concerning area of borders. You can see in 2011 there were 2 questions, question 46 and question 38. In 2011 there are 2 questions, 2010, 1 question, 2012, question 48, 2013, question 27, and question 7. That's up to 2018, which is question 40 and question 45. So if you check your KCPE papers, you'll find such questions. Now we will move to solving the problems. These ones, I extracted them from different materials. I want us to go through them one by one. As you can check the first one, if you check the first one there, that's there are 2 things there. We have a square and also we have a circle. Let me bring it back to you again. You can see a square inside, a square outside a circle. How do you find area of such a thing? That one, I have to take you back to the formulas which we had. And our formula of a circle is pi r square. Pi is a constant figure which is always 22/7. Area of a square side by side. We'll use side by side because that's the one we have been given there. If you check that one there, we have been given side by side, and that one, if you check that question there, we have been given radius of a circle and sides of a square. So square is the largest figure there, a circle is the smallest figure. So let's find the area of a circle. Let's find the area of a circle. Area of a circle, there you can see it is pi r square, and pi is equal to 22/7. Pi is equal to 22/7. Then pi 22/7, radius we have been given there as 3.5. So we'll say area is equal to 22/7 times radius, which is 3.5, times 3.5. What will that one give us? When we say 22/7 by 3.5 times 3.5, that one will give us a figure like 38.5. Now we are done with the area of a square. Now area of a circle. Now we are going to find the area of a square. Now let's come to area of a square. Area of a square is equal to side by side. And if you check that that circle there, if you check that circle, you can see side is 7 and side is 7. So we say 7 by 7, that one gives us 49. Now, how do you get the area of the shaded? Area of the shaded is the area of the circle. Area of the shaded is the area of the circle take away from the area of a square, which is 49 take away 38.5. That one will give us a figure like 10.5 square centimeter. Let's move to the next question. The next question is also a bit complicated, but if you are keen, you have to break those things or those figures or those shapes into parts. If we go back, you can see we have 4 semicircles and 1 rectangle inside, and we said, how do you get the area of a rectangle? Area of a rectangle is length times width. That will be 56 by 28. 56 by 28 will give you 1568. Then you have to find the area of semicircle on the right side, and the semicircle on the right side is the same as semicircle on the left side. So by finding the area of semicircle on the left side, you will multiply that answer by 2 because they are the same. Then you check the semicircle on the upper side. Semicircle on the upper side is also similar to semicircle on the lower side, and I want you to try that one. Make area of a semicircle is equal to 1/2 times pi times r square. R square means r times r. So after getting the area of a semicircle on the upper side, multiply by 2, and area of the semicircle on the left side, multiply by 2. Then the answer you get from the semicircles add to area of a rectangle which is at the center. Let's move to the next question. Next question, as you can see, there are 2 questions there on the board. And the first question you have been asked, find the area of the figure below in square centimeter. The first thing the last thing there, square centimeter, before you have been asked to use pi as 3.14. If you check that figure, it has a sign of 90 degrees somewhere, or that's a point of intersection where line of 24 centimeter joins line of 18 centimeter. That one is not that is not a quarter circle. There are 2 shapes there. I want to show you that there are 2 shapes there. If you check, if you have a figure like that, and here is 4, here is 3, here is 3, we can't take this one as a quarter circle. We are going to take this as 2 shapes. Whereas we are going to find the area of half a circle plus the area of a triangle. What do we do in such a situation? We are brought back to Pythagorean theorem, which is right angle relation. And if you check there, we said a square plus b square is equal to c square. A square, that is 3. A and B, A, B, C. So A and B must be the two sides which make right angle. That is 3 and 4. So we will say 3 square is equal to 9 plus 4 square is equal to 16. That gives us a total of 25. So 25, what do we do with the 25? Remember, we are told a square plus b square is equal to c square. So we have to square root 25 to get this side. So 25 square root. 25 square root gives us 5. Then now this side is 5. This side is 5. So you have now the side which was missing. This one will help you find the area of the semicircle, and remember, you are advised to use pi as 3.14. So pi as 3.14, we are going to say now area of a semicircle is equal to a half by pi times r square, whereas a half is a half times pi. We have been advised to use 3.14 by radius, which is that 5 is diameter. So we use radius as half of diameter, which is 5/2 times 5/2. I think that's now clear up to there. When you check that, or you will get the answer for area of a semicircle. Then you come to area of a triangle. You also do the same. Remember, I'm just demonstrating. You are working out with your paper at home. Area of a triangle is equal to half times base times height, whereas a half base is 3 and height is 4. When you work out the answer you get here and the answer you get here, what do? You add them. Then that one you can demonstrate clearly. We have two shapes here, and this one I want to challenge you. When a same question is brought this way, it can be brought this way, whereas they advise us here, this side and this side are the same. When you get this one, now you have to be careful. This is now quarter circle. It is one shape. If you decide to draw line in between, you are going to distort it. This is just quarter circle. In case we have here 7 and here 7 centimeter, what do you do with that? Or you say area of a quarter circle is equal to a quarter pi r square. Then you say a quarter times 22/7 by 7 is radius, not diameter. Why? Let me show you. If I decide to make it a whole circle, let's assume that's a whole circle. How many quarter circles will you have? You will have 4 quarter circles, which means from here to here is diameter. So from here to here is radius. So this one should not confuse you, because most learners take this one, this 7 as diameter, though it is radius. And that one also work with the quarter circle, with the 3/4 circle. 3/4 circle, if I draw like this way, I will have 3/4 circle like that. What we have here is radius, and for it not to confuse you, please always have ability of extending, so that you can know from here to here is diameter. So this one is radius, and now you will say area is equal to 3/4 pi r square. Then now pi is constant, 22/7, unless you are advised to use 3.14. Radius is what is here and this one here. Okay, let's now move to the next thing. We will move to the next one. Up to there, I hope you have some concept concerning how to work out area of combined shapes. You realize you have to break them into workable shapes. You can't work a shape which is complicated. For example, if I combine a quarter circle and a triangle, that one, it has no name, so I have to break it. So whereas now I will have quarter circle and I will have triangle, because at the beginning, what did we realize? At the beginning, we demonstrated the formulas, and those formulas, make sure you always consider them. Let's move to the next question. That one brings us to this one. You can see in such a case, for example, let's read. The figure below shows a square drawn inside a circle of radius 3 centimeter. A square drawn inside a circle of radius 3 centimeter. Remember, it is the square inside the circle. Then we are asked to find area of the shaded part. So you have to organize the shapes which are there, because the main shapes they have mentioned, they have said a square inside a circle. But if you check that shape, those combined shapes, you will see quarter circle, you will see triangle, and some shapes with no names, or we can call them segments. Some of them we can call sectors. So let's go back to the question. If you check that question there, for example, if we have a question like this one here, if this is the circle, then this is a square. The square is inside the circle. This shape, it has no formula, this one here. And that's what we call segment. Segment like this one, minor segment and major segment. Don't confuse it with a sector. We have sector, minor sector, and major sector. So this one we have said is segment. And this is sector. So this is minor sector, major sector, minor segment, major segment. So for this one, how to identify a segment and a sector. If you check sector takes it from the point O. We call it center at the point O. Remember, from here to here, from point O, for example, to point A, that is radius, and from O to B is radius. But for the segment, it is not that case. It's just part of, which means you can decide to continue dividing it. For this one, it is like bar graph. Sector is like bar graph. We can have many like that. Yes, that's now we call sector. And that one now will help us solve these questions, because this one is a segment and it has no defined formula. But remember, sector has a defined formula. If I take it from the center here and I draw a line like this, we were told radius is 3. If radius is 3, now radius is 3, here is also 3. This is the center O. Now how will you get the area of this shaded part? How to get the area of the shaded part? You first take this approach. They have told us this is 3 and this is 3. Let me take you back to that. You can see they have divided that circle into 4 parts. Now we can also do that. We can bring it this way and we can also bring it this way. Then if you check there, this one is also shaded. But for these people, they decided to shade it up to here, and this one is also shaded up to here. So we are asking you find the area of the shaded part. Use pi to be 3.14. Now what do? The first thing you ask yourself, what do you have the shaded part? Does it have a name? Yes, this one. It is sector. And sector, because they have told us here and here is 3, which means this is quarter circle. So we say area of the shaded is a quarter pi r square, which is a quarter times 22/7 times 3 times 3. The answer you will get there, that's a quarter times 22/7 times 3 times 3 can give you a figure like 7.065. 7.06065. Then you also do another one for a quarter circle, the same, because this one is the same as this. You can also multiply this one times 2. Then you'll get 14.13. Or back to the next question, it's neighbor question there. The other question, now this one is tricky, and you have to be careful because you can see they have only given us the segment. They have not given us the sector. Let's try that. Now this one, circle, from the center, sorry, we can do another one. I can see that one is not giving a clear picture. So if it is this way and this way, they have decided to shade this one and shade this one. You have to be very careful here, because, or if you check here, you can push this one to be here, which means you can make it so that we can have a semicircle with the shaded segment. For example, if this is shaded, I can decide to shade it here, then this one unshaded. So what will I have here? I will have, what will I have here? I will have a semicircle. What do? Find area of a semicircle, which is half pi r square. Then find the area of a triangle. Remember, from here to here, there we are given as 21. So from here to here is also 21. So by the time you are finding the area of a triangle, make sure you use base as 42 and height as 21. Remember, from here to here is 21, here to here is 21, here to here is 21, here to here is 21. So half times 42 times 21. What will you get? 693. Sorry, you will get 441. Then when you come to area of half a circle, you say half times 22/7 times 21 times 21 will give you 696. And when you take away this one now, we take away, we don't add. You must be careful where to take away and where to add. Why? Because this one is not there, and this semicircle is there, and they have removed the triangle. So here we take away, we don't add. 441 take 441, take away 693. It will give us 252. Good. Now we will move to the next question. If you check this one here, this one is the same as the one on the right side. Check it well. The one on the right side is almost the same as the one we have just solved. If I take you back, you can see a semicircle removed from, a triangle removed from a semicircle. What about the one on the right side? The one on the right side is also the same. A triangle taken away from a semicircle. But there's something you must know. The diameter or radius of the triangle we have not been given. So you have to use Pythagorean theorem. Pythagorean theorem will help us get the side which we are not given. If you check that figure, whereas a triangle has been taken away from a semicircle, you realize you have been given base and height of a triangle. We have not been given the hypotenuse, and that hypotenuse is the one we represent with C. So we have to find C square. We say C square is equal to base or A square plus B square. So that one brings us to Pythagorean theorem, and that's why if you check the formulas we started with, that was the first thing which we gave. So make sure that formula is always at your fingertip. Let me try for the last time concerning it so that we can solve it. Or for example, you can see it is drawn this way. It is drawn this way and this way. Then you realize there is a triangle. This one is shaded, this one is shaded. Always be careful, don't take these ones as semicircles. These are not semicircles, these are segments of a part of a circle. So if they say this is 90, and if they say that one is 90 there, and this side is 42 and 56, 42 and 56, so we are going to use Pythagorean theorem. Say 42 and 56, which means you want the larger side. When you want the larger side, we add, and that's the C square, whereas we said C square is equal to A square, which is 42 square plus 56 square. And make sure you follow this procedure we had followed first, because there's one we did here. You can see this one here, whereas we said this and this one gave us 25, and we did the square root and we got 5. So follow the same procedure. When I move to this one on the left side, read with me, find the area of the shaded part in the figure below. Remember, that is quarter circle. Why? I told you if the sides are the same, it is quarter circle. So what do? This is what you do. This is what you do. Is this way and this way. This is quarter circle. They have just extended this one to be this way. Then this is 14 and this is 14. So what you do? Make sure you do this way. Make a line here. Why am I doing that? I want to find, well, okay. Let's before we move to the next one, there's something we need to solve. Someone is requesting we do something here. You can see this is a semicircle, and this semicircle will say area is equal to a half. That's now area of a semicircle. Area of a semicircle, half times pi times r square. That will give us, and the radius you will use here is the hypotenuse, half of hypotenuse, half of it, because we will get here up to here. So the area will be half of the hypotenuse. It is what we will use as radius times radius. Most learners assume radius square is radius times 2. No, radius square is equal to radius times radius. 2 radius is diameter. So please don't use this one. We are using radius square. Assuming you get your radius as 70, you say 70 times 70. Don't say at 140 here. This is, if it is 70 times 70. Then you find the area of a triangle. With a triangle, don't use this one as the base. Base and height of a triangle are the two lines which make right angle, whichever side they are facing. Most of us assume base must face the lower side. No, we can have base sometimes like this way. So make sure you use the two sides. So you say half times 56 times 42. And remember, this this triangle has been taken away. So you take away area of a semicircle to area of a triangle. Okay. You will find out the answer is 749 square centimeter. And now we can move on. Now I want to go to the last one we are going to solve here, then we will tackle some KCPE questions. This is the last one we will tackle. I want you to check those figures keenly. What have you seen? A triangle, a rectangle, a semicircle, a rectangle, a triangle, and another right angle triangle. So let me just take you back there, as you see it well. There are two right angle triangles. The one on the upper side, you can see where the sign of 90 is, and the one on the left side, you can also see where the 90 is. So those are the ones which will make the base. I know up to now you know how to find the area of a semicircle, half pi r square. That's on the lower side. You know how to find the area of a rectangle, which will be length times width 20 times 7. Now the challenge is with the triangles, because if we check our upper triangle, we have been given only one side. Remember, diameter of that semicircle is the base of the upper triangle. So now I have base, I have hypotenuse. I want height. What do you do? This is what we do. If you have been given a figure like this is 25, this one is 7, this is the one missing. The one missing is smaller side. So if this one is meter and this is meter, remember our formula, c square is equal to a square plus b square. Then what do? C is 25 because it's the longer side. We say 25 times 25 give us 625. A square is 7 square, which is 49, plus b square, which we don't have, we say b square. Then now we collect like terms. We take this 49 to this one. Because this 49 has a sign of plus here, any figure without a sign here has a sign of plus. When you bring it the other side, it will change to be minus. You take away 400, you take away 49. When you take away 49, what will you get there? I want you to work out with me. 576 square meter. What do you do to get you square root and get 24 meters. Then here is 24 meters. So if that part is 24 meters, what now do you need to do? Now we are going to find the area of a triangle. Area of a triangle, we said it is half times base times height. Half times base, our base is 7 and our height is 24. Here we are not going to use 25 when finding the area, because when finding the area of a triangle, we use the two shorter sides which make right angle. So that one now bring us to this one. When you want to find the area of this, you say area is equal to a half times base times height. Then this one, here 1, here 12. 12 by this is 80, 84 square meter. Now by that, now already you have the area of the first right angle triangle as 84. Then now we will also come to this one. If you check this one, we have also the shorter side, which is 16, and the longer side, which is 20. And if you want to save time in case you are in exam room, you just identify the shorter side, the longer side, and the shorter side. So I need the shorter side. What do? I take away, which is 20 square. It gives us 400. Take away 16 square, 256. You will get 144. When you get 144, you square root, you will get it is 12. Now 12 meter. What do we do with 12 meter and 16 meter? They're the ones which make here, you say half times 16 times 12, which will give us 90. Half by 16 times 12 will give us 96. So meter square. Now you have the area of the triangle. You have the area of the two triangles, because they are the ones which were not given the sides. Already now we have them. So what do? We go to the area of a semicircle. Area of a semicircle. Area of a semicircle. We say, oh, now semicircle is this with a diameter of 7. We say area is half times pi times r. 7, because this is diameter, so we use over 2 by 7 over 2. I think we are okay up to there. Then this one we can cancel this. This one can go with this one as 11. Then now you will have 77 over 2 will give us 38.5. So this, sorry, it is over 4. Over 4 should not give us 38.5, but it is supposed to give us 19.25 square meter. 19.25. Then you come to the area of the rectangle. Rectangle, I know this one is taught in class 4. Length times width. 20 times 7 gives us 140 meter square. So you add them. What do you have now? 140 add to 96, add to 84, and lastly add it to 19.25. What did you get? You will get good. You will get 339.25. You'll get the area is 339.25. Someone is wondering, why have we added all of them? There's none which was removed. We can only remove, for example, if you check this semicircle here, for example, if you have a thing like this one now you can subtract. You can only subtract if the semicircle is on the is this way. Now this is the time you subtract. This one now you will subtract after adding this plus this plus this. This one you take away. But for our situation, it was outside. We add it. We add it. Now I want to take you this one. Now you will try it, but let me just explain. This one is a good one. I want you to check this point. This point is inside. You will say a quarter pi r square. That we have a quarter pi r square. 7 is radius, 7 is not diameter. Remember what I told you the other side. That one is the only one you take away from there. What about this one here? This one you add, and this one you add. And where do you add it to? You first, because here you're told the figure ABCD is a square of sides 32, which means from here to here is 32. So I say 32 times 32. That's the first thing you do. You put it aside. You come to the semicircle. You say half pi r square. What you get? Add. 14 is diameter. Radius will be 7. You come to 3/4. This 3/4, 7 is radius. You say 3/4 times pi times r times r. Now what you get here, you add. Do all the additions first. 32 by 32, what you get, add to the area of semicircle. Add to area of 3/4 circle. Then lastly you take away area of quarter circle. Now these are KCPE questions. I will only try 2017 with you, so that you can also try others at home. You can see that is 2018, and that's number 40, and 2018 number 45. Then 2017 is also there. You check number 27, number 16 is the one we will solve. Then 2016, 2015 and 2014. Make sure you also solve those ones at home. We have 2013 and 2012. We have different shapes there. And now let's go to 2017, which will be our last question. So if you check this 2017 question, you will realize that there are different shapes, two shapes. On the upper side we have trapezium, and with the trapezium, okay, we can solve it here. We said trapezium is equal to h over 2 into a plus b. If you check a we have as 56, b we don't have, it is this one here. And what are we supposed to do? We say here to here is equal to 21. Sorry, is equal to 56. So 21 is here. This is also 21. We are still going to use Pythagorean theorem. Let me draw it. This is 21. It is the same as this is 21. Here to here is 56, will be the same as here to here, which is 56. Then what do? Do we have this one? We have hypotenuse as 35. When you have hypotenuse 35, now we use Pythagorean theorem to get this one, base, which is the shorter side. And we said, getting the shorter side, what do? We take away. So 35 times 35, 12, 25. Then 21 by 21, 441. And we are taking away because we want the smaller side. What do we get? We will get 784. When you square root 784, you will get 28. So here is 28. Now 28 plus 56 is our B, because A we said is 56, plus B is from here, because they must be two parallel lines, that's the A and B. So from here to here is equal to 84. When you add a 56 plus 84, you will get 56 plus 84, you get 140. 6, you will get 140. You get 140. I think I'm right. Am I right? Then now height here is 20. Remember, height is 21. So this is 70. Then 21 times 70. What do you get? 21 by 70. Yes, 21 by 70. I hope all you are learners, you are helping me. 1470. That is 1470. And if you check here, they were in meters, so you say square meter. Then now you find the area of semicircle. I think we have done semicircle several times. Find the area of semicircle, add by, then what you get, you add to what is there. Thank you for your time. Have a blessed day.